The Interchange is brought to you by AES Energy Storage, a pioneering and world-leading storage developer and now energy storage solution provider. We are entering a new era, the electrification of everything, and the grid needs to keep up. That means making it into a more distributed, flexible, and cleaner network. AES Energy Storage is helping unlock the true power of the electricity system with Advancion. Advancion is a battery-based energy storage platform that helps utilities modernize their power systems rapidly and at a much lower cost than traditional infrastructure. It is time to unlock the full potential of the electric power system. That means building a new energy network, transforming the grid with energy storage, accelerating renewables, and electrifying everything. That's the vision and mission of AES Energy Storage. To learn more about AES's offerings, visit aesenergystorage.com/interchange. This is The Interchange, weekly conversations on the global energy transformation from Greentech Media. I'm Stephen Lacey in Boston. Welcome. In this episode, we are tackling blockchain. You've probably heard this term thrown around a lot recently. Over the last 18 months or so, blockchain has morphed from an obscure concept in cryptocurrency circles into a mainstream corporate tool for disrupting entire industries. If you don't have a blockchain strategy, you are not innovating hard enough. And if you're like a lot of people, when you hear someone confidently use that term, you may politely nod your head, afraid to truly ask, wait, what is it again? We're going to provide some context and explore how it's already being applied to utilities and energy markets. But first, I think Richard Hendricks, the nervous but brilliant software engineer in HBO's Silicon Valley, can help us wrap our heads around the spirit of blockchain. Not the technical component per se, but what it represents.
All right, let's do an exercise. You've got unlimited time and resources. You can build anything in the world you want with your compression, anything at all. What's it going to be? 3, 2, 1, go.
Outside. I don't.
Go.
You said I have unlimited time.
Now.
A new internet.
What? Why?
Okay, well, I haven't really thought this through, so... Okay. I own a telescope.
Of course you do.
And, I brought it out one night to look at the full moon.
Of course you did.
And, I got to thinking, wow, we put a man on the moon using the computing power of a handheld calculator. And then I thought, okay, there's literally millions of times more computing power in my phone, and that's just sitting in my pocket, doing nothing, right? So then I thought, there's, billions of phones all around the world with the same computing power, just sitting in people's pockets. So then I thought, what if we use all those phones to build a massive network? And here's the kicker. We use my compression algorithm to make everything small and efficient, to move things around, and if we could do it, we could build a completely decentralized version of our current internet with no firewalls, no tolls, no government regulation, no spying. Information would be totally free in every sense of the word.
You want to build a new internet?
Yes.
Richard, I like it. That I would fund.
Well, I don't know.
Okay, so that's essentially what people believe blockchain will do to the financial sector, healthcare, energy, whatever. Create a decentralized transaction system that will bypass the traditional gatekeepers. So let's explore further. Our team was out in San Jose this week for our Grid Edge World Forum, and blockchain was discussed on stage on numerous occasions. So I sat down with my co-host and GTM Senior Vice President Shayle Kann and GTM CEO Scott Clavenna for a closer look.
All right, so blockchain is obviously hot. It's quite hyped now, I think, in electricity circles. So I want to kind of talk about, whether that's warranted. But let's start at the most basic level. Can you give a pretty brief and clear description of what blockchain is, and then we can talk about applications in electricity?
Sure. All right, so blockchain at its basic is a distributed ledger, meaning that currently any database that holds records of operational or financial transaction tends to be centralized, owned by a third party. I guess in this case we'd be talking about a utility or any kind of financial organization that manages trading and settlements. Blockchain being a distributed ledger means it resides with the market participants, and there is no intermediary. So whoever is involved in the transaction or the operation has a distributed ledger, a copy of it sitting on their computer, their node, whatever it is. And what that does then is it effectively, in a perfect world, disintermediates the process of needing a third party.
All right. So in electricity, we have like an independent system operator that manages wholesale markets, right? And they're managing the trading of electricity and, real time and day ahead markets and things like that. Are you saying that like through blockchain, you could disintermediate that whole process and like eliminate the need for the ISO to manage wholesale electricity markets?
There's a long-term vision where that's possible. There's a sort of a new ISO where it's really just in charge of sort of maintaining the actual market space, whatever it is that blockchain resides on, but the actual participants. So it would create a situation where it could be much more low cost and efficient to sort of operate a grid, because the participants now, there's transparent information about generation, consumption, transmission, power flows. It's all being recorded, and it's recorded in a blockchain that everyone has access to and resides in a distributed fashion. And so it resides at the edges or at the points of the network. And with Ethereum or any other blockchain that has smart contracts, the beauty is, again, in the long-term vision, this isn't quite what's happening now, but the long-term vision is with smart contracts, that network can operate to some extent autonomously, because the smart contract element of a blockchain means that as information is sent to it, it can act on that information without any third party authorizing it, validating it, running any process. Like as you generate, it's recorded, and as you consume, it's recorded, and you can get paid without any intermediary. There is no bank. There's nothing in charge of validating that the energy was produced, validating that it was consumed, validating what having an index that sets the price for that transaction. It's all just built into the blockchain, and it resides at every node, and it can act as it occurs. Like the blockchain itself starts and ends the transaction and settles it.
All right, what you just laid out there, the implications are vast. I mean, like, you're talking about a complete restructuring of the way that markets work. But you come to these conferences and people are like, blockchain, artificial intelligence. Like, they throw around these big buzzwords without, like, real thought about how this stuff kind of plays out. I don't want to, like, make too many assumptions. I think they're very thoughtful steps that people are taking to implement this stuff. But, like, walk us back to what people are doing today. We're talking about very small peer-to-peer sales of electricity, small verification systems. Like, what's the near-term play for this right now that sort of walks us out to that market-changing scenario?
Right. Actually, what I just described is part of the problem, is that it's very easy to describe a future in which the utility disappears. The grid is literally just a network of wires and endpoints, and there's generating assets and users and management of it. It's easy to describe that, and so it's very easy to hype that's where blockchain is taking us overnight. Where the reality is, there's a ton of obstacles to get there. Just the maturity of the blockchain, the security of it, the transaction processing power and speed of it. So the disconnect right now is people tend to leap ahead to that vision and think it's coming immediately, when the reality is blockchain's not quite ready for that. What it is ready for are networks or transactions with very few participants and with very little need for speed. And so the current pilots tend to be wholesale energy trading settlements, where there's just a big trade of energy and it just needs to be settled. There's not millions of transactions per second or anything like that. It's one or two a day. Or in the case of EV charging roaming, that your car or your card, with your EV would have your identity on a blockchain, and then any charge point, any charging station you went to would recognize that, validate it. The transaction would happen immediately. There's no third party that, you don't have to use It's not tied to your bank or anything like that. It all just sort of, it's a digital identity and a smart contract that is initiated by the fact that you're charging. So there's simple things like that that are being piloted, and even that has some bugs in it. They need to work out like how it is settled, what the financial currency is, anything like that, if you're roaming out in different currency markets. But in general, blockchain gives you a way to make transactions tend to be lower cost than currently and potentially just more efficient.
All right. But so I drive my car and I go to a gas station and, I input my credit card and it can recognize who I am via my credit card and I can pay instantaneously. It's a very seamless process. Like, is the theoretical benefit of blockchain? I've heard that EV roaming idea before, and it sounds cool until I think about, I think I have all of that today. So is the benefit just that it's going to be cheaper because my Visa card is tied to Visa and Visa's taking a cut and that cut goes away? Is that the primary benefit?
Well, that's one. I think the other benefit is the notion of you being tied to your utility, and you can roam among other utilities and roam among owners of EV charging stations. And so it's a little more like kind of like Wi-Fi, something like that, where you can, or even cell phones where you roam into different markets, and there's a way in which your identity is recognized, and then there's a communication among them to share your minutes and settle that among them. This is somewhat similar to that it could really simplify how you do EV charging. And in the next iteration of it, they're not trying it now, but where that could go in the future, especially if your vehicle's identity is tied to your utility, it can go in either direction. You could plug in and your car could become a grid asset at that time too, and you could get compensated if the grid actually needs to draw from your car while you're parked. So now you could have an ongoing blockchain-based digital relationship with the grid, and you are now a generating, or you're a resource, a distributed resource on the grid.
And one could imagine that this is important for verification systems. Everything from the tracking of solar renewable energy certificates to corporate renewables procurement to credits for deforestation credits and carbon emission reductions on an international scope. You have all these verification systems in place, and if you take out interested parties that may be able to manipulate data or have a hard time tracking it themselves, then in theory you put in place a more efficient system.
There's a lot that's happening in supply chains across the economy. There's a great application for blockchain as provenance of proof of state, proof of work. It is like an immutable record of whatever has happened, and for generating renewable energy credits, things like that, or if you're in a carbon market that can be gamed and hacked. This is a relatively unhackable way to manage that.
You mentioned at the beginning a few times that one of the benefits of this is that all the ledger exists at the node. So it's a distributed ledger. All the information exists at every node. And I'm just struggling to figure out why I care. Why is it better to have all the information exist at every node instead of all the information centralized, but I can access it just like everybody else? Like the stock exchange, we can all access prices on the stock exchange remotely now because we have the internet. Would it matter if all those prices were sitting on my machine?
The reason that you hear blockchain is the distributed ledger is better than a central ledger tends to be, one, it's much more secure than a centralized ledger. It is almost impossible to hack. There have been cases where it's, because blockchain is early enough in its maturity that there's a way to manipulate it, to kind of fool it into thinking it's validated a transaction when in fact it hasn't. But in general, if you distribute a ledger and copy it, and you only let a transaction be recorded on a ledger when every other node, or at least a meaningful number of nodes, have, through this cryptographic computational technique, validated that transaction did occur and it's okay to put it into the chain, then you can't hack it because it's distributed. Now, you could hack one node, but every other node will say that's wrong, right? It can only be distributed to every node through consensus. And so part of it, and that's where it's born out of Bitcoin, is that the notion that it needed to be unhackable. And so part of the long-term idea is if everyone, to relate it to the electricity system, if everyone becomes an energy consumer and generator and a point on a transactive network, that notion of security becomes really critical, and that and the efficiency of that network then, and so the cost efficiency of operating that network can be quite good because there is no third party. Everyone is just transacting among themselves. The network is running somewhat autonomously, and the cost of these transactions are extremely low because it just happens automatically. As you generate and someone consumes, it just happens.
What is the sense you're getting from executives in this space? Let's say utility folks. How are they thinking about applying this stuff? I get the sense that some are walking into their offices and CEOs are saying, go find me this blockchain. And others are legitimately identifying problems where it could be applied and thinking thoughtfully about near-term applications. Anything interesting out of this conference?
Yeah, I think I definitely get the sense from utilities that they're at least over the hump of acknowledging they need to get it. They need to spend some time with it, devote internal resources to understanding it. And a lot of them, there's over 50 pilots now. So a lot of them are at least saying, I need to have a pilot. Let's run something. And it's some wholesale energy trade or some operational technique they can do to lower costs. So you're finding that in every other industry, financial industry, healthcare, insurance. Every industry is doing this, is at this ongoing pilot phase. Electricity is probably one of the slowest to adopt, probably of all the blockchain adopters.
No.
It's particularly American utilities are the slowest of all the utilities. Europeans, Australians are way ahead of us. Their market rules make it easier to kind of jump into this, and even just their sense of adopting distributed, or decentralized networking is a little ahead of ours. So they're all into it in the U.S. I think they're all aware of it and into it, but there's definitely still a lot of skepticism. And the reality is, blockchain being tied to cryptocurrency does not help it in our industry. And if you look at, or what may start happening is you'll likely hear a lot of conversations around distributed ledgers and not blockchain. Because I think the term blockchain is getting a little tainted by all the craziness in Bitcoin and Ether.
A quick break here to mention our sponsor, AES Energy Storage. AES owns $36 billion in energy assets and serves electricity to over 9 million people worldwide. 10 years ago, AES set up its battery business, and since then the cost of installing grid-scale batteries has dropped nearly 90%, thanks to more efficient installation techniques, lower-cost hardware, and better lithium-ion batteries. That same trend took hold in the computer industry, where rapidly declining data storage costs revolutionized our digital networks. Lithium-ion batteries are now bringing data networks resiliency and responsiveness to the electricity network by enabling multiple hours of storage. The grid is changing, fast, and AES Energy Storage is helping utilities harness the power of battery-based energy storage to make the electric power system cleaner, more flexible, and more reliable. Visit aesenergystorage.com/interchange to learn more.
Yeah, also, the fact that there are a whole bunch of pilots, this is a classic electricity industry thing. Utilities love pilots. There's so many pilots. Whether it goes, from pilot to meaningful scale adoption is a different question. So, they've gotten over the hump on let's pilot something so that we can say we have a blockchain pilot or a distributed ledger pilot. But I guess the question is what is the first real scaled application that you will see? And also, sort of how does it work from the utility perspective? Are they going to implement blockchain for something on the distribution grid and then rate base their expenditure on blockchain? I mean, how does it fit within the regulatory model?
Yeah, that's interesting. I would think what's going to happen is utilities will play around with pilots, find a few applications that don't require any regulatory change, and what is more likely is blockchain will kind of come in or disrupt from the outside. There will be some private microgrids, campus, I have a feeling blockchain you'll see get really stress tested in microgrids as both a way to manage distributed energy resources and those assets, and then monetize them, and that will get sort of blockchain in the electricity system from the outside in. And it's possible, if history is any guide, utilities will sort of plod along, not make a lot of progress. Some outsiders will, with microgrids or other kind of distributed community, some kind of community energy networks, and running on the blockchain, and that will force sort of local regulations to change, and then that'll make its way into the utility system.
I mean, one has to look at the experience of DER adoption to see how it sort of forces sets of regulatory changes. But one wonders if the regulatory morass in the utility sector is going to stop this from taking place. Like you have, like let's say you develop a blockchain-based microgrid. I mean, you still have utility franchise rights. You still have all these interconnection agreements. Like there are basic legal and physical constraints to developing these projects that blockchain can't necessarily get you around.
You're right. But I would say that my advice would be to look outside the U.S. That in China, in Southeast Asia, Australia, parts of Europe, it's a lot easier for them to adopt this. The regulatory frameworks, either if it's an emerging market, don't quite exist in a way that they can't just make a wholesale change. Or in Europe, they can be just very progressive about allowing this as it matures. And so I would say what's very likely to happen is we'll see a lot of activity outside the U.S. It'll get mature, and then that understanding will start to inform how it comes into the U.S.
Yeah, I wonder about in emerging markets for like rural electrification. There's a lot of talk about microgrids, rural microgrids in places where it's hard to extend the grid, and they really, the benefits of blockchain being that it's, you can't pirate it, and it's secure, and it's cheap, and it's efficient. Those are things you really need when you're trying to build a microgrid in a rural community that doesn't have access to power. So I wonder whether that's actually an early sort of adoption.
Yeah.
And this is a much more sophisticated extension of the mobile banking systems we're seeing in developing countries, where they can bypass traditional financial institutions, get credit, and build wealth in a way that they couldn't through central banking.
Mm-hmm. Well, that's actually where a blockchain network that the transactions are in Bitcoins or Ether or some cryptocurrency that resides on top of it is kind of this long-term vision of blockchain enabling a whole new economy. And the economy then disintermediates utilities, banks, all the major centralized institutions, and every participant in that economy, blockchain, is their store of value. Because ultimately that's what you're transitioning to, is from, like, we have an internet of data, we have an internet of things. The blockchain is essentially the internet of value. And once value is distributed like that, and everyone has their own ledger, their own store of value, then you do have a whole new economy. And that always works best in emerging markets.
Internet of value is a good phrase. Okay, but still, like, the electricity grid is a physical asset, right? And, the role of the utility is, let's just say it's a lines and wires utility. Like, it has a partial role that I feel like you can see how it could get disintermediated by blockchain in the managing the actual trading and the operation of the system to some extent. On the other hand, they also manage the lines and wires, and somebody's got to continue to do that. So, like, blockchain can change the nature of the utility, but I have a hard time seeing it displacing the utility entirely.
Well, what if it's the notion of the utility as in the retail, the DSO? So you could pay a charge to the DSO to be a participant, and the blockchain is the way you get compensated for whatever you're generating, and it's the way you pay for whatever you're drawing from it. So the utility remains. The utility just transforms. It's a DSO, whatever it is, but it's someone that's owning the physical plant of the electricity infrastructure, and the blockchain is the way in which you transact across that.
Right. So the vision here, the DSO, so this is a distribution system operator. This is an idea that John Wellinghoff came up with, and he wanted it to be an independent distribution system operator. So it actually wouldn't be the utility in his version of it, right? And so you'd have the way that we manage the wholesale markets now, you'd manage at the retail level as well, except instead of there being an entity sitting there like ERCOT or ISO New England or whatever, it's a blockchain. And then the utility kind of and there's somebody managing the blockchain, I guess, the system, but like they have a pretty minimal role. And then the utility still exists, but they are purely lines and wires. They are like physical assets and no more.
Yeah, that is a vision that has been at least described as one in which the blockchain solves the problem of how do you transact, how do you store and trade value across that network. Blockchain gets you that.
This is one of those topics where I simultaneously drop my jaw to the floor thinking about the implications, but chuckle a bit thinking about like the corporate, the empty corporate strategies that are being developed around this concept. How do you think about it, Scott?
I would argue it's coming. I think blockchain, there is so many people. A lot of how you can tell if something's coming is just the amount of engineering effort going into it. And I think there are so many. It started out very raw and very loose federation of weirdos working on it just to print money. This was the basic, original concept of this is like, how can a bunch of digital nerds print money? And so there are a bunch of them that got extraordinarily rich creating a new currency, and then there's enough liquidity in the markets now that they can trade that and get extremely rich. But the good news is all the work they had to do to make Bitcoin or Ether really secure and reflective of this like underlying distributed digital economy makes the blockchain part of it ideal for the transformation of these other industries. And so I think it's inevitable. It's coming. My guess is that we'll see it do a lot better in other industries first, and electricity is going to be somewhat on the sidelines, just watching and trialing, but you'll see it in the financial industry, in insurance, in healthcare, in municipalities, anywhere where you need like good unhackable records. And once that's really well proven, then the IBMs of the world, anyone who's building these really robust distributed ledger solutions, they can come to the electricity market then and say, all right, this is solid. You can go to work with it.
To some extent, that's not any different than any other technology adoption in the utility space. I mean, you think about everything we do on our mobile phones, and utilities are just now saying, like, wow, we've got this cool mobile app to talk to our customers, right? So you could imagine it taking hold in other sectors and then moving into utilities.
Also, a loose federation of weirdos should be the episode title for this podcast. Greatest description of how blockchain came to be that I've ever heard.
That is the Grid Edge World Forum, a loose federation of weirdos. Thanks, Scott.
All right, thank you.
Okay, that's the show. Thanks for listening. If you like this podcast, give us a rating and review on iTunes. We recently brought the show public, of course, and helping us out on iTunes goes a long way to getting us new listeners. Thanks also to AES Energy Storage for being our launch sponsor. We're off the week of July 4th for vacation, but we'll catch you the following week. I'm Stephen Lacey, and this is The Interchange, weekly conversations on the global energy transformation from GreenTech Media.